Good morning, students. Till now, we have learnt about introduction of haloalkane and various method of preparation of haloalkanes. Today, we are going to start about physical properties of haloalkane. First of all, physical state. Lower haloalkanes are gaseous in nature, but as we increase the mass of the carbon chain, there is a change in state from gaseous to liquid and then to solid, because we know that mass of solid compound is higher as compared to liquid and then gases. So as we increase the number of carbon atom, mass also increases, which ultimately increase the physical state of the compound. For example, chloromethane and bromomethane are exist in gaseous phase, whereas chloroethane exists in liquid state. We have another example, 1,2-dichlorobenzene and 1,3-dichlorobenzene exist in liquid state, and 1,4-dichlorobenzene exists in solid state. It is an important compound. Second, color. Most of the alkyl halides are colorless in nature, but bromide and iodide develop color when they are exposed to light, because in some cases we need some ionization energy to excite their electrons. So in case of bromide and iodide, their ionization energy is lower, so they excite their electron and show color when they are exposed to light. Third, density. Density is mass upon volume. As we increase the number of carbon atom in alkyl halide, mass increases. Volume also increases, but here mass is an dominating factor because volume increases only in picometer. That's why number of carbon atom increase the mass, and which leads to increase in density of the compound. For example, like chloropropane, bromopropane and iodopropane. As we move from left to right, mass increases and density also increases. Similarly, we have another example, dichloromethane, trichloromethane, tetrachloromethane, and in this case also density increases, because as we increase the number of chloride atom, mass of the compound increases. Next, melting and boiling point. Melting and boiling point of students basically depend upon three factors: molecular mass, surface area and branching, and in some cases symmetry also play an important role. For example, if van der Waals forces of attraction increases with increase in molecular mass, similarly this force also increases, and we can say it is directly proportional to surface area. Van der Waals forces of attraction also directly proportional to symmetry of molecules, but it is inversely proportional to branching in carbon chain. We have example. For example, we have an alkyl halide like Ri, Rbr, Rcl, Rf. As we move from left to right, van der Waals forces decreases because R remains same, only change in halogen atom. And as we move from left to right, mass decreases, so boiling point also decreases. Similarly, in case of CH3Cl, CH2Cl, 2 CHCl3, CCl4, mass increases continuously as we increase the number of chloride atom, so boiling point increases. Take another example. In case of haloarenes, iodobenzene is having higher boiling point as compared to bromobenzene and chlorobenzene. This is important. In case of isomeric compound, if we have different same alkyl halide but having branching, as we know that van der Waals forces of attraction decreases with increase in branching, so as we move from this compound to this, molecular mass remains same, surface area decreases, weak van der Waals forces of attraction decreases and boiling point also decreases. This is a important example of our NCERT book also. Next, this is a orthochlorotoluene. This is a metachlorotoluene. This is a parachlorotoluene. These three are also isomer having same molecular mass but have different melting point. Here para is having higher melting point than ortho and then meta compound, because as I told you, para compound is symmetrical in nature, that's why it is having a higher melting point. But in case of ortho, plus R effect or we can say resonance effect play a important role. So order is para, ortho and meta. Similarly, this is another NCERT example, 1,2, 1,3 and 1,4 dichlorobenzene and order remain same. Next, solubility. Here is a NCERT question. As alkyl halides are polar in nature, but they are having less solubility in water. Why? Because alkyl halide is an polar molecule and water is also a polar molecule which contain H bonding. If one part of R combine with H, then it have to dissociate that amount of energy and new bond formation also release some amount of energy. But this new amount of energy is not sufficient to break the molecule of Rx. That's why they are not soluble, or we can say these are slightly soluble in water. And we can write the answer of above question in this way: because Rx to dissolve in water, energy is required to overcome the attraction between Rx molecule. That's why less energy is released when new attractions are set up between Rx molecules, so there are less solubility in water. This is another important physical properties of haloalkane dipole moment. We have learned in class 11th, dipole moment is represented by Q into D. Charge and distance factor decide the dipole moment of a molecule. As we talk about alkyl halide, it is a CH3F, CH3Cl, CH3Br, CH3. Electronegativity of the fluoride atom is higher than chloride atom, and as we move from fluoride to iodide, electronegativity decreases. So expected order of dipole moment will be CH3F is higher, CH3Cl, then CH3Br and then CH3I. But there is an exception. CH3Cl is having higher dipole moment than CH3CF, then last order remains same. Reason: in case of chloride atom, the size of chloride atom is higher, but in case of fluoride atom only charge separation is higher. But in case of chlorine, we have, if we see about Q into D, it is some amount higher as compared to fluoride atom. That's why there is an exception, chloride move first as compared to CH3F. Similarly, there is another example of fluorobenzene and chlorobenzene, order is same as shown above. This is another NCERT important example. 1,4 dichlorobenzene, 1,2 dichlorobenzene, 1,3 dichlorobenzene. As we know, it is an symmetrical molecule. So theta is 180 degree and dipole moment is cancelled. So para molecule is having zero dipole moment, and we know that those molecules which are having zero dipole moment are insoluble in water. But in case of 1 2-dichlorobenzene, theta is 60 degree and cos theta is 60 is 0.05, whereas here angle is 120 and cos 120 is minus 0.5. So dipole moment of orthoisomer is higher as compared to meta, and para due to symmetry it is a lowest dipole moment. Similarly, another example, CS2, Cl2, CHCl3, CCl4. We know that CCl4 is an symmetrical molecule. That's why its dipole moment is 0. It is insoluble in water, but chloroform and dichloromethane having some dipole moment. So they are partially soluble in water or having some dipole moment. But dichloromethane is having higher dipole moment than chloroform. So students, we have covered all the physical properties today. I hope this lecture will be useful for you. So keep watching and subscribe our YouTube channel